Hi, everybody. My name is Anshul, and today I'm going to talk about interaction effects and a few ways that we can visualize them. So keep in mind you can pause and rewind the video anytime you need. And so we'll get started by asking a simple research question, which is, does going to the beach instead of staying at home make your day better or worse? So that's the question we're going to try to investigate here. And what we did is we collected some data about this. So you can see there were 4 days on which we collected data. On some days, we either went to the beach or not, and the weather was either sunny or rainy. So the weather is another variable we're adding into our data as a consideration here. And then, of course, our outcome of interest is the dependent variable, which is level of fun. So that is what you see here in this column. And that's measured on a scale from 0 to 100. Okay, now to answer our research question, we can put the data in an easier to read format like what you see here. So what we have here is that we have a 2x2 table, and the red numbers in the middle are our level of fun that we had on each of the days where we took data measurements from the previous slide. So on a day when we stay at home and the weather is sunny, we experience 70 units of fun. But then if on that sunny day we go to the beach, we experience an additional 30 units of fun, moving our fun level up to 100. But now let's say it's a rainy day. Let's say the weather is rainy. Then if we stay at home, we experience 50 units of fun just by staying at home on that rainy day. But if we go to the beach on that rainy day, we don't have a very good time at all. We only have 10 units of fun if we do go to the beach on that rainy day. So what we can see here is we can start to formulate some results. So the first is this. As I mentioned before, if we just look at what happens on a sunny day alone, then we would be looking inside of this box that I'm drawing in blue. And that box tells us that if on a sunny day we go to the beach, our fun increases by 30 fun units. But now, let's say we go to the beach on a rainy day instead. On that rainy day, what's going to happen is that our fun will decrease from 50 fun units down to 10. And now we have our results back on the right. And so you can see the lower result shows negative 40 additional fun units. So the effect of going to the beach on our level of fun is positive 30 fun units if the weather is sunny, and it's negative 40 fun units if the weather outside is rainy. And so let's revisit our research question, which is, does going to the beach instead of staying at home make your day better or worse? The answer is that we can conclude that it depends. There's no single answer. And what does it depend on? It depends on the weather. So you can't just make a blanket statement, hey, going to the beach makes our day better, or going to the beach makes our day worse. It depends on the weather. And so this is what we call an interaction effect between activity and weather. So there are two independent variables, activity and weather, and they are interacting when it comes to our measurement and conclusions related to the dependent variable, which is fun. And so here's the conclusions. If it's sunny out, going to the beach makes our day better. If it's rainy out, going to the beach makes our day worse. So this is an interaction effect. And in this interaction effect, weather, the variable weather, is what we call a moderator variable, because the effect of our activity, going to the beach or not, on our level of fun is moderated by whatever the level of the weather is, which it could be sunny or rainy. Okay, now we're going to turn to a different way to visualize this same scenario. And what we see here is what's called an interaction plot. And in this interaction plot, we're putting all of the same information that we just had in the 2x2 table. So on the x-axis here, we have the level of activity. So there's two possible levels of activity. One is to stay at home, and another is going to the beach. And then we have two separate lines for our weather variable. There's two possible outcomes for our weather variable. One is that the weather is rainy. The other is that it's sunny. And so we have two separate lines, and then we have our level of fun on the y-axis because that's the dependent variable, and that's always where we put our dependent variable is on the vertical axis or the y-axis. Okay, so now let's quickly review and demonstrate that what we have on this interaction plot is the same as what we had in the table on the previous slides. So let's start with the scenario in which we go to the beach and the weather is good, it's sunny. In that scenario, right here, we have 100 units of fun, just like on the previous slides. But now, what if we stay at home on that same sunny day? Then we have 70 units of fun. Now let's switch to the scenario where the weather is rainy. If the weather is rainy and we still decide to go to the beach for some reason, then we're going to look over here at this dot right here in the circle, and we're going to see that we only have 10 units of fun on a day like that, where we go to the beach in the rain. On that same rainy day, if we stay at home, which is this vertical dimension right here, if we stay at home, we get 50 units of fun on that rainy day when we don't go to the beach. So all of the same numbers are now translated onto this scatter plot here. And we've just joined together the 4 points with an orange line up here and a blue line down here to make this visually a little bit easier. And now we can draw some conclusions, which are going to be the same conclusions as before, but with slightly different terminology. And we're going to derive those conclusions directly from this interaction plot. So let's get our first one. So the question we're going to ask first is there what we call an activity effect? And the answer is yes. So the question we're asking is, as we change our activity from staying at home to going to the beach, does the level of fun change? And we have to look at this at both levels of the weather. So let's start with the rainy weather condition. In the rainy weather condition, as we move from staying home to going to the beach, our fun level moves from 50 to 10. So since it did not stay constant, since it changed, we'll conclude there is an activity effect for the rainy weather condition. Now let's check it for the sunny weather condition. And we see that on a sunny day, as we move from staying at home to going to the beach, our level of fun also changes. It doesn't stay at 0. So the amount of change, is different for the two lines, for the rainy and the sunny, but there is a change. And so we say that there is an activity effect. The effect of activity on fun is not 0. All right, now let's look at it in a different way, which we did not focus on when we presented this scenario with the 2x2 table. Now we'll ask if there's something called a weather effect. So the weather effect is, now let's just look at one level of activity, which in this case is staying at home. Only looking at staying at home. Let's compare the scenario where it's rainy with the scenario where it's sunny. And so that difference can be visualized here. As the weather changes from rainy to sunny, our level of fun changes from 50 to 70. So that's a change that's not 0. So that means when we look at the staying home condition of activity, there is a weather effect. Now let's do the same for the activity condition where we go to the beach. If we go to the beach on a rainy day, our fun level is 10 down here. And if we go to the beach on a sunny day, the level of fun is 100 up here. So as we changed the weather, because now we're talking about the weather effect. So we're looking at it from the new perspective of the weather. As we change the weather just on a beach day, our level of fun goes up from here all the way to here. So there is a not zero weather effect in both activity conditions, stay home and beach. So we'll conclude, yes, there is a weather effect. And now the next thing we'll ask is there an activity times weather interaction effect? And this is where the answer is exactly the same as what we've already discussed from the previous slides, that, the change in fun level on a rainy day is -40. It's 50 to 10. The change in fun level on a sunny day, when you compare staying home to going to the beach, it goes from 70 to 100. That's +30. So those numbers are the same as from the previous slide, and we've already discussed them. So there is an activity times weather interaction effect. The size of the activity effect is not the same in both of these lines. It depends on the weather. And then there's also what we could call a weather times activity interaction effect. That's not how we framed our research question. Our research question today has been more about going to the beach and how does that associate with our level of fun. But you could, if you wanted to investigate what is the impact or association of the weather on our level of fun, you could look at the weather times activity interaction effect, and you would find the very same thing, that the magnitude of the weather effect, which we've already reviewed before, that magnitude is right here, +20 units, going from 50 to 70 when you stay at home and the weather is sunny rather than rainy. And if you go to the beach, that weather effect, meaning comparing the rainy weather to the sunny weather, goes all the way up 90 fun units. So that size over here, when you stay at home, is 20, and here it's 90. And those numbers are not the same. So it depends on whether you stay home or go to the beach as to what the weather effect is going to be. The effect of the weather on your fun depends on what activity you did. So that's why there's both an activity times weather and also a weather times activity effect. Of course, both of these have to happen together, but we just weren't wording it that way until now, which is why I took a little extra time to point that out. Okay, now let's talk about a scenario. What if there had not been an internet interaction effect? Then what would our data have looked like? So let's first look at the data we had before. So this is the same thing you've already seen. And now let's add new data. If there had not been an interaction, what is some hypothetical data we would have seen as a result here in this table? And let's walk through it. So there's one number that's different, which is that we changed 100 to 30 over here. So now what we're saying is it doesn't matter if the weather is sunny or rainy. No matter what, your level of fun if you stay home is going to be higher. So our level of fun if we stay home on a sunny day is 70, like before. But now if we go to the beach on that same sunny day, our level of fun is 30. So let's imagine this new data is collected on somebody who just doesn't like the beach, right? So their level of fun is going to go down by 40 units. It's going to go from 70 to 30 if they switch from staying at home to going to the beach. Now let's look at this same scenario on a rainy day. On a rainy day, if we switch from staying at home to going to the beach, we move from our initial 50 fun units down to 10. So in both columns, whether it's sunny or rainy, if you choose to move from staying at home to going to the beach, you decrease your fun by 40 units. Your day gets worse. It gets 40 units worse. And the weather doesn't matter. That's the key here. It goes down by 40 when you go to the beach. Your fun level does, no matter the weather. So there's no interaction effect. The weather has no bearing on the effect of going to the beach. And that's why we say there's no interaction effect here. And what we'll do next is we'll visualize it here. So this is a very similar interaction plot, but now, as you can see, the effect for both rainy weather and sunny weather condition is the same. And so as if it's a rainy day and we stay at home, we now have 50 units of fun. If we go to the beach on that rainy day, 10 units of fun. So it's a decrease of 40. And then if it's a sunny day and we stay at home, still 70 units of fun. But if we, on that same sunny day, go to the beach, remember, we don't like the beach anymore in this scenario, then we go way down to 30 units of fun. So in both cases, in both of these lines, the rainy and the weather, they're going down, the rainy and the sunny, that is, they're going down by 40 units. And these two lines are parallel, which also helps give us a clue that there's no interaction. So we can write some results now. Here's the first result on the screen. Is there an activity effect? Yes. So as we change from staying at home to going to the beach, our fun level changes by -40. So there is an activity effect. There is an effect on your fun based on what activity you do. Is there a weather effect? Yes. Again, we didn't focus on it in the setup, but there is a weather effect. Let's say we just stayed at home and we compared weather scenarios. As you move from rainy weather to sunny weather, you go up from 50 to 70. So you go up by 20 units. And if you go to the beach and the weather is rainy, you have 10. If you go to the beach and the weather is sunny, you have 30 units of fun. That's also an improvement of 20, the same as what it was here. So now we're starting to get some clues, right? The magnitude of the activity effect was -40 from here to here and from here to here, regardless of the weather. And then regardless of our activity, the change in weather from rainy to sunny took us up on our fun scale by 20 units in both home and beach scenarios. So this reveals that there's no interaction. So there's no activity times weather interaction, meaning the size of the activity effect is always -40 fun units. Doesn't matter what the weather is. And then we can also say the weather effect is also 20 fun units, no matter what activity we look at. And so there's also no, so this I believe is a mistake on the slide here. There is no, I'll just fix it. And there it is, it's fixed. There is no weather times activity interaction effect. There's no interaction effects in this scenario at all. There's just a activity effect and a weather effect on their own. The level of the other variable has nothing to do with the size of those effects. Okay, so there's no interaction. Now let's keep moving to a new scenario. So let's review the old scenario is on the left. We had two independent variables, one that we cared the most about, which was activity, and the other was a moderator, as we reviewed, which was weather. Both of these independent variables are categorical variables. Categorical. They're qualitative in nature. They don't have numbers. Our dependent variable was fun score. That did have a number. But now let's talk about a new scenario in which the dependent variable is going to be heart rate. So this is still measured in beats per minute, still a continuous numeric variable. But now we're going to have a new independent variable called minutes of exercise. And then we're going to still have a moderating independent variable, which is categorical. And those categories are going to be the competition level of the person engaging in exercise. So whether someone is a professional, amateur, or recreational athlete. And so we won't go fully through this scenario, but we'll just show that, look, it's possible to show this as well on an interaction plot. So here on the x-axis, we have the time you've spent doing exercise, and we see how people's heart rate change as they do more and more exercise. We see that professional athletes, their heart rate does not go as much. They all start around the same level when they're at 0 minutes of exercise. But then the professional athletes on average, after 100 minutes of exercise continuously, their heart rates don't go up as rapidly. An amateur athlete's heart rate will have a steeper slope in its increase over the 100 minutes of exercise. And so that orange line in the middle there is steeper than the line for the professionals. And then the steepest line is the recreational athlete. The recreational athlete, their heart rate goes up the most if they really push themselves to exercise 100 minutes. So since these slopes are different, so the research question we answered here is, what's the relationship between heart rate and minutes of exercise? And the answer is that it depends on the level of competition. So anytime you're talking about an interaction effect, you're interested in the relationship between a dependent variable and some independent variable of interest right here. But the answer about what is that relationship is going to depend on who you're talking about, meaning the level of another independent variable, which in this case is your competition level as an athlete. And we can see that visually because the steepnesses or the slopes of these lines are different. So you can't just say that, okay, everybody's heart rate increases the same amount for every additional minute of exercise. Instead, you have to say that it depends on which group you're in. And the heart rate goes up the most for recreational athletes. It goes up the fastest. And for professional athletes, it doesn't go up nearly as fast at all. That's an interaction effect involving a still continuous numeric dependent variable, but now a continuous numeric independent variable as well, with the moderating variable of competition level still being categorical. So you draw one line for each of those moderating levels, and then you see that it's a different slope. Okay, and that concludes our video, everybody. Thank you very much for watching and for your desire to learn about interaction effects and how to visualize them.